All right, in this video, we're going to do an extension of area between two curves, but we're going to do it with respect to y. Sometimes it makes sense to change your top and bottom functions to go sideways. So you would draw in your bar kind of like this. And so as you scan that region, like your multiple bars are going to be like this. And so we go from y equals c to y equals d. Your top function then needs to be in terms of y, and your bottom function has to be in terms of y. So you can almost turn your paper over and think about this is now your top minus this is now your bottom. This is your smallest y value to your largest y value. And so we would set this up as the integral from c to d of u of y minus v of y dy. Now, why would you want to do that? Well, if you were to try to keep it in terms of dx, you might have to split this into like 3 different regions. And so that might be one reason why you're like, do I want to do 3 different regions, or do I just want to flip this so that my boxes go the other way? So it's kind of up to you as to what you want to do on these, but this is one way to make it simple, or even some of the things you can't find them with respect to x. If you had, let's go ahead and say, like, if you were to have x equals y squared, and you wanted to go top minus bottom, well, that's going to be really tricky. You could make this like the positive root x and the negative root x. You could double this area, or you could just integrate with respect to y, and you don't have some of those issues you might have with having the same function being your top and bottom. Okay, so this is just, again, one more tool you can use, if you will, in your integration techniques. Okay, so we're going to do this 2 different ways. We're going to do this with respect to x first, then with respect to y. So with respect to x, I see I have an intersection point here at x equals 1. And my bottom function is actually always the line y equals 0. And so from 0 to 1, my top function is x squared. But from 1 to 2, my top function is this line. So if I wanted to integrate this with respect to x, I'd say, like, okay, area 1 goes from x equals 0 to 1 of top function x squared minus bottom function is y equals 0 dx plus the integral from 1 to 2 top function minus bottom function dx. Now you don't need to do the minus 0. That's how we found area back in Cal 1, but you could just for the simplicity and like the consistency of it. All right, so I would end up having 1/3 x cubed from x equals 1 to 0. And this is why if you've been in my classes, you will see I was starting to get you to do like x's and y's from the beginning so that you can start integrating with respect to the right terms and plugging in correctly. So you're doing everything in terms of x's here. All right, this is 2x minus 1/2 x squared is the antiderivative from x equals 1 to 2. All right, so then I plug in 1. So 1/3 minus, I plug in 0, 0, plus 4 minus 1/2 of 4 minus, we're going to plug in 1, 2 minus 1/2. So 1/3 plus 2 minus 3/2. Let's see, 6. So 2, 6, and 9, 6. 2 minus 7, 6, 12, 6. This is going to end up being 5, 6 as our area. All right, I'm going to erase this part here. to give you an example of how we do this in terms of y. So if I wanted to integrate with respect to y, I draw my little bar this way. So this is my top function. Now I need it to be in terms of y. So we're going to say equals y, negative x equals y minus 2, and x equals negative y plus 2. And that's g of y. Okay. That's going to be my top function. My bottom function is y equals x squared. If I take the square root of both sides, x equals square root of y, and that's going to be my f of y. I start at y equals 0, and I need to integrate to 1. So integral from 0 to 1 of top function, we said was negative y plus 2, minus bottom function is square root of y, and I'm integrating this with respect to y. No like terms, in this part right here. So I get negative 1/2 y squared plus 2y minus, y to the 3/2 times 2/3 from y equals 0 to 1. I'm going to go ahead and plug in 1. When I plug in 0, everything goes away, and I get negative 1/2 plus 2 minus 2/3. And you'll see when you go ahead and simplify that, you get 5/6.